Welcome, Dr. Manoj Karkee. Thank you for interviewing with us.
Oftentimes, we say it's not rocket science because we say rocket science is the most challenging problem out there. It used to be, and it is still a very challenging problem. But we have already been to moon and landed there. And rocket science has been to a level. It is done by a lot of companies, and a lot of individuals have done it. Apple harvesting, on the other hand, is quite challenging too. Sometimes I claim that it's more challenging because we have not finished doing it. It's not just because it's more challenging, perhaps it's also because what we need in agriculture is a machine that is simple, that can be used by farmers, is cheap, because farming is not an industry that can afford millions and millions of dollars like a rocket, or hundreds of millions of dollars in some cases like rockets or space technology. So there are other challenges with robotics for agriculture, as I just mentioned. That's why we have not achieved commercial success in agricultural robotics like apple harvesting yet. However, in recent years, from around the world, like my research program, there have been a lot of other research programs as well as private companies like FF Robotics and Abundant Robotics that you guys have included in your video. These are actually, you guys covered the major efforts that are going on out there.
Okay.
We are closer than ever. We are closer than ever, but I would still say that it's still a few more years that we might need to further develop and make these machines affordable and reliable for farmers. Okay. So maybe another 2 to 3 years, we would start to see a few of them working, and then maybe another 5 years, you would have many more in the farm. There are a few different ways we can go about picking an object. We can have finger type hand, like what you saw in my prototype. You saw vacuum sucker in the prototype developed by Abundant Robotics. You saw kind of a cup type of arm or hand in the machine that was developed by FF Robotics. There are scissor cutters that are out there. There are other kinds of end effectors or hands developed by different researchers. So first of all, research is an avenue. We explore everything possible and see what works best, right? That's part of the reason why I'm working in one kind and some other folks are working in other kinds of technologies. And each of these have their own advantages and disadvantages, or pros and cons. With vacuum sucker, whenever there is a branch in front of an apple, it is difficult for the sucker to get the apple without damaging it. Versus finger type mechanism might go around a little and then have possibility to detach it or pick it without damaging it. Whereas you might have noticed that vacuum sucker is much faster because it doesn't have mechanical parts to be moved to close around the fruit. It just sucks it in. So what we call pneumatic, the system that uses air, can be faster than hydraulic, where we use oil or water, or electrical systems where we use electrical motors to close things or do something. So anyway, these are different ways we do it. We push our own ways to see how well it works, and if we find out that one works better than other, companies might pick from the best one they see out there. As a researcher, I have to be open in terms of what are the possibilities and try whatever I can to show their viability and their pros and cons. That's the reason why we have finger type. We have optimized these fingers from 4 fingers to 3 fingers. We have also recently developed a much different kind of fingers that are operated by pneumatics or air, which are faster than the mechanical ones, but maybe still slightly slower than the vacuum suctioning. However, again, there are pros and cons, and industries would perhaps pick one or the other depending upon what they see value in.
How difficult is it to teach a robot how to recognize the right apple?
Great question, Carlee. We started, as I said, with a few different components that go into a robotic system. The first one I mentioned was what I call sensing system or machine vision system. Those are like our eyes that see things using cameras, and these cameras would have two types of information. One, color information, meaning the very similar way our eyes see, different types of colors. And then the other one is distance from the sensor, from the camera to where the objects are. If you compare with our eyes, we have two eyes for a reason. Certainly one reason is that if one eye gets somehow disabled, other one would still keep working. But the other aspect of it, if you have not already noticed it or learned about it, these two eyes create a system called stereoscopy. What it allows us to do is that with the processing of images captured by two eyes by our brain, we get the estimation of distance to an object, how far an object is from us. To prove that, I can tell you one thing. You close one of your eyes like this, and then try to walk around. And after a while, you'll start to feel like, I don't know how far that table is. I don't know if Dustin is 5 feet from me or 10 feet from me. That's exactly the same way we do in robotics. We use two cameras separated by some distance, and they'll capture two images. These images are analyzed with very capable modern algorithms, also called deep learning. And there are other techniques out there, but deep learning is one of the newest, what we call artificial intelligence technique that allows us to understand color, shape, size, texture of these objects that we are imaging, and also using two images collected by two cameras, we estimate the distance to these objects.